Alright, so here is the notes for Unit 9, Day 4. We're going to be multiplying and dividing rational expressions. So again, rational expressions, they can be written as a fraction. Any expression that can be written as a fraction, so it has a top and it has a bottom. And when we say multiplying and dividing, we do some multiplying, but we hardly ever divide. We do some factoring, we do a lot of canceling. So for the most part, we're just doing a whole bunch of factoring and canceling. It's not really multiplication and division. But our learning target, I can multiply or divide, simplify their results completely, which simplest form here is when the numerator and the denominator have no common factors. So you have it simplified completely when they share no factors on top and bottom. And we also want to be able to state restrictions. So first off, just some simple ones. Think back to middle school how you would do this. And even I'm going to go even simpler than that. Let's say if I want to simplify this, I need to factor it. So 2, that's prime. 3 is prime. 9 can be written as 3 times 3. And then 14 can be written as 2 times 7. And now I'd look at the factors on top and the factors on bottom. So there's 3's on top and bottom. There's 2's on top and bottom. And then what's left would be 3 on top and 7 on bottom. So 3/7 would be the answer. No restrictions, there's no variables. So there's nothing that can make the bottom equal 0. It's 7. If you remember, when you're dividing, we can't divide, but we can flip and multiply. So for this one, I'd have 3/5 times, and then I need a 25 on top, which would be 5 times 5, and then 12 on bottom, which would be 2 times 2 times 3 if we do the primes. So doing some factoring here, the 3's cancel out, the 5's cancel out. All that's left then is 5 on top and 4 on bottom. Again, no restrictions because there's no variables involved. Up here, and you probably realize you can cancel a little faster than that. Like 14 and 35, I get to divide them both by 7. So that'd be what, 2 and 5. And then the 2 and the 22, that'd be a 1 and 11. I kind of did it this way because that's going to be the way we do when there's variables involved down below. The 5 and the 20, 1 and a 4. So I got 4 times 1 on top, 11 times 1 on bottom, so it'll be 4 11ths. And then over here, 12 over 40 times 6 over 15. We're going to flip and multiply. So flip the second one, then multiply. Things in common here. Let's see, if I divide that by 3, it'd be 4 and 5. What would this be, like 3 and 20? And then I could do 1 and 5. So it's going to be 3/25 when it's all said and done. So that's just the basic way of doing it. Now, we're going to do the same thing here. And I've done some factoring. I tried to speed the video up, so I've done a little bit of the factoring ahead of time. This guy, instead of 15x cubed, I'm going to write as 3 times 5 times x cubed. And then I've already flipped and multiplied and factored. So once you get everything all factored out, just start canceling. So cancel the 3's. Actually, I should say before we cancel, let's do our restrictions. So as this is written, there's a way that y can make the bottom equal 0, and that's if y was 0. If I plugged a 0 in, this would become 0, and the whole bottom would be 0. Also, x is right here, so x cannot be 0 either. So I am going to do my restrictions before I cancel. That's going to make life a whole lot easier. Back to it now. Cancel the 3's, cancel these 2's, cancel the 5's. Now I got y times y, and then I got a y squared on top. Well, y times y is y squared, so I could actually just cancel all of these at once. And then I got x squared on bottom, x cubed on top. So 2 x's being multiplied together, we'll cancel out 2 of those, which means there's just 1 left. Okay, so in the end, everything on bottom got canceled, so they're all a bunch of 1's. On top, I've got 2 and x. That's it. So the answer would be 2x as long as x is not 0 and y is not 0. Flip it. Okay, and it's already factored. You can't factor anything out of all of these, so remember last unit, I can't just cancel the 9's, but I could cancel 9x minus 1. If the entire binomial matches, you can cancel those out. So I got x plus 2 over 2x plus 1. I forgot again. Go back to your original restrictions. So what would make this equal 0? And remember, if it's 9x minus 1, if I set it equal to 0, I'd bring this over, which means I'd switch the sign. So it'd be a positive 1 and then divide by 9. So 1/9 here, switch that sign, it'd be a negative 1 and then divided by 2. So 1/9 and negative 1/2 would make those, would be my restrictions. Okay. Our letter C. I could try to factor, but nothing factors out of any of these. They're not both divisible by 2 or 3 or 7 or 4. Nothing comes out. So these are the factors, and notice nothing cancels. So this would be my answer right here. I could really just go like this, leave it in factor form and say that's my answer. It can't be simplified, but m is not allowed to equal. Again, switch the signs to be a positive 2 over 3. And then here, switch that sign, so it'll be a negative 3 over 2. So that's the answer, and these are the restrictions. For letter D, it's multiplications, no flipping, and I've already factored. I took 4 out of both of those. So I'll just put a line through those. I've already taken a 4 out of both of those. And now I'm going to do my canceling. X plus 3, the entire binomial. If the entire binomial matches, then you can cancel them. And then x minus 5, x minus 5. So the answer is 4. Go back to the original problem. X cannot equal 5, x cannot equal negative 3. Okay, so the answer is 4 as long as x isn't 5 or negative 3. Letter E. I'm going to remember to do my restrictions first this time. Y, what would make that equal 0? It would be 0. Here would be a negative 2. Here would be a positive 2. Okay. Now, start doing some canceling. I got a 3 here and a 3 here, but that 3 is not a factor, so I cannot cancel. I got a y here and a y here. That y is not a factor, so I cannot cancel. But y minus 2 squared, I just wrote it as y minus 2 times y minus 2, and one of these can cancel that guy out. Doesn't matter which one of them could cancel. So my answer, I'm just going to leave it factor 2. You don't have to re-multiply this out. Don't ever worry about foiling it back, multiplying it back together. So 3y times y plus 2. But that'd be my answer with those restrictions. And then on bottom, again, I just flipped this one over. So flip the numerator and denominator over. Everything's factored for me, so that's nice. Look at my restrictions here, okay? So x could not equal, this would be a positive 3 over 2. It's repeated, so I'm not going to put it twice. Positive 2 over 5 and 4. So x cannot equal any of those numbers. Now start doing your canceling. Okay, so x minus 4, x minus 4. And all I'm left with then is 3x plus 1 over 2x minus 3 with those restrictions. Okay? All right, flipping this over now, we're going to look at some that they're not factored for us. So we got to do some factoring first and then do it. I'm actually going to do A, B, and C. I'm just going to leave D. We're going to leave it blank. I'll do A, B, and C for us. So doing some factoring here. Remember, two numbers multiplied give me a negative 35, and the sum is 2. So that'd be a positive 7 and a negative 5. And then over here, product is negative 21. So I know I've got a 1 plus 1 minus. That'd be what, 7 and 3. So the sum is 4. And I like to just put a line through those because I'm done with those. I've replaced those. And now x cannot equal 0, 3, or negative 7. Because if it did, that bottom would be 0. Now start doing some canceling. X plus 7, x plus 7. Here the x's, 5 and 10 would be a 2 on bottom. So this would be x minus 5 on top, and then 2 times x minus 3 on bottom with those restrictions. Okay, so there's the answer as long as x doesn't equal that. Here, I took a 6 out of both of these, and that's what I was left with. Here we got x, and again, product is negative, so it's going to be one of each. One's plus, one's minus. And if the sum is 2, that'd be 5 and 3. So the sum was negative 2. Up here, Again, I got a negative product, so it's minus plus. And this one would be minus 4 plus 3 to give me a negative 1 for a sum. Out of these three, I took a 3 out. So do this, I'm done with that, but I can go further. Okay, so this should be a squared. It'd be x, x, and this looks like negative 4, positive 1. Okay, so then cross that guy out. So now, looking at the bottom here, x cannot equal 5. It can't equal negative 3. It cannot equal 4, and it cannot equal negative 1. So we got 4 restrictions here, and x can't equal any of those. Now start canceling. So the first one I saw, second one, and then just a 3 and the 6, that'd be a 2 and a 1. So it looks like I got 2 times 2x minus 3 on top, and then x minus 5 times x plus 1 on bottom. And then down here, kind of got everything involved here. So I got division, so I already flipped it over. I bought the x plus 4 up top here. I'll factor that guy on bottom. But doing some factoring here. So the bottom one might be easier, so I'll do that. So this would be x and x. The product is negative again. The sum is a positive 2, so that'd be 4 and 2. This guy, if it's 2x squared, and notice there's nothing they're all divisible by, so I can't pull something out front. So that means it must be 2x and x. And I gotta get a little creative here. I gotta do some outer plus inner. So the product of these two is gonna be negative 10, but I have to do the outer plus the inner to find a positive 1. So I think 5 and negative 2. So this would be a 2x squared. That'd be a minus 2x plus, I'm sorry, minus 4x plus 5x is a positive 1x. And then if I multiply 5 times negative 2, I get negative 10. So that's the 1. And then over here, nothing can be pulled out of all those. There's nothing they're all divisible by. So I could do 4x and x, or I could do 2x and 2x. We say normally the numbers are closer together. Like 2 and 2 are the same number, whereas 4 and 1 are kind of further apart. And then two numbers that multiply give me 5. And if I do outer plus inner, so 2x times 5 plus 2x times 5, that'd be 10x plus 10x is 20x. So now I got it factored. Restrictions would be negative 4, 2, and this is repeated, it'd be negative 5 over 2. Okay, negative 5 over 2. And now if I start doing some canceling, almost everything goes away. Now there's nothing left on top. These are all 1s, because when you cancel out their 1s, that means there is still a 1 on top, and then 2x plus 5, given those restrictions. Okay, so again, if you're struggling with factoring, maybe refresh yourself on those. That you can shoot me an email, or you can maybe go to Khan Academy or something about factoring if you're struggling with that. But that was from our quadratics unit. So really, this is just a whole bunch of factoring and then canceling. So let me know if you have questions.